sensitivity analysis seeks to ask is very simple. What if? What if any of these variables change over the long term? Would the project still be viable or worthwhile? In evaluating every investment project, there are two main things that are considered: the benefits. We'll look at the benefits and the costs. Now, the benefits include the sales revenues, the disposal or the scrap value, the working capital release, the tax allowable depreciation, and the rest. The cost involves variable costs, operating costs, such as fixed costs. You can also look at inflation. Inflation becomes a cost. The cost of capital, the tax paid, the tax paid. You can also look at working capital, investment in working capital, and many more. Many more variables come into NPV calculations. What sensitivity analysis is basically seeking is that when we consider all these variables and the NPV of a project is positive, is above 0, then we accept the project. But what if these variables, as stated here, change over a period of time? Because you realize that for any investment or capital budgeting project, it spans a long period, so it's a long-term project. And any of these variables used as basis for evaluating the project can change over the long term. What sensitivity analysis seeks to ask is very simple. What if? What if any of these variables change over the long term? Would the project still be viable or worthwhile? Or not worthwhile. Or not worthwhile when any of the variables change. So how do you compute a sensitivity analysis? How do you undertake a sensitivity analysis? To undertake a sensitivity analysis, you use a simple approach. So the sensitivity analysis is the NPV of the project divided by the present value of the variable under consideration. So let's take, for instance, that we want to look at the sensitivity of a project the sensitivity of a project revenues. The sensitivity of a project revenue. So sensitivity and analysis. Okay, so the sensitivity of project revenue. So it's going to be the NPV of the project divided by the PV of the revenue. Okay, so now if we want to find the sensitivity, let's say another example is that we want to find the sensitivity of a project to the let's say to the variable cost. That is going to give us, so the sensitivity analysis of the variable cost is going to be the NPV of the project divided by the PV of the variable cost. Likewise, if you want to find the sensitivity of a project to the fixed cost, is going to be the NPV over the PV of fixed cost. Okay, so how do you find the PV of the fixed cost, PV of revenue, PV of the variable cost? Now let's use one example, the PV example that we solved and the SC example that we solved. Okay, so let's look at the sensitivity analysis of the PV example that we solved. Now we are going to do the sensitivity analysis of the sales revenue. We are also going to do the sensitivity analysis of the operating cost, the initial investment, then we also look at so under the operating cost we are going to look at the variable cost, and the fixed cost. Okay, now when you look at, let's look at the sales revenues. When you look at the question, you realize that after we did the computation, we had revenue of okay, so year 1, year 2, year 3, year 4. For year 1 we had 1, 2, 3, 6,000, 148, 1,485, 400. Year 3 was 2,622,000, and this is 1012950. Okay, so these are the revenues. But when we want to do sensitivity analysis of, let's say, revenue, it's going to be the NPV over the PV of revenue. Now when we did the computation, realize that the NPV of the PV the NPV was 366,722. So that is the NPV. But we need to find the PV of the revenues. So in order to find the PVs of the revenue, we need to discount them. So we use a discount factor. According to the question, the discount factor was 10%. Okay, so 10% for year 1 will give us a discount factor of 0.909, 0.826, 0.751, and 0.683. So when we multiply this by this, we are going to get the PVs. So let's do the multiplication. Let's do the multiplication and see what we are going to get. So the first one that we need to compute is 6,000 multiplied by 0.909, and we are going to get 112. We are going to get 1123524. The next one is 14859, 1485400 times 0.826, which will give us 1126940 to the nearest whole number. The next one is 262622123 times 0.751, and this one will give us 1969122, and the last one is 1012950 multiplied by 0.683. This one will give us 691,844. So okay, so 845. So when you add all this, you are going to get the PVs. So there's first one 1123524 plus 1126940 plus 1969122 plus 691,845. So this one will give us 491111431. Okay, so the sensitivity, okay, so the sensitivity of this implies that sensitivity analysis of revenue is equal to 366722 divided by 4911431, and this one is going to give us 366722 divided by, let me write this well, 722 divided by 4911431. So this is going to give us 0.0746 or 7.46%. What does this mean? What at all does this mean? The 7.46. What is the intuition? What is the intuition of this? What is the intuition? Now the intuition is very simple. Every company expects its revenue to increase over a period. Expects its revenues to increase over a period. Therefore, if the revenue of the project falls by 7.46%, the project will not be worthwhile. So the intuition simply means if the revenue of the project falls by 7.46% over the period, the project will not be worthwhile. That is the intuition. Okay, hope you understand. Now let's go on and find the operating. Now okay, now let's go to the let's go and find the sensitivity analysis of the initial investment. So that one is going to give us the NPV divided by the PV of the initial cost. Now what is the initial cost? The initial cost okay, so the initial cost of the project is 2 million, and the 2 million occurs in year 0, right? You understand? It occurs in year 0. The present value, the discounting factor of 10% for year 0 will give us 1. Therefore the PV is going to give us 2 million, because 2 million multiplied by 1 will give us, so this is the cost, this is the discount factor, 10%, and so the PV is going to give us 2 million. Therefore the sensitivity analysis is equal to the NPV, which is 366,722 divided by 2 million, and this one is going to give us, so 366,722 divided by 2 million. So this one will give us 0.183 or 18.3%. What does this mean? What is the intuition? Sorry. What is the intuition? What is the intuition of the 18.3%? It simply means that for every company, every company wants its costs to reduce. No company wants its cost to increase. It wants its cost to reduce. So what this means is that if cost of investment increase by 18.3%, the project will not be worthwhile. That is the intuition. That is the intuition of what we've done so far. Okay, so now let's go to the operating cost. We are going to combine, I'm going to combine the operating cost, that is the fixed and the variable cost. I will not segregate it into the variable cost and the fixed cost. I will leave that to you to do it if you really understand what I have done so far. Okay. Okay. Okay, so the operating cost, the total operating cost of the PV co, the total operating cost. So for year, so total operating cost for year, so year 1, year 2, year 3, year 4. So we look at the discount factor of 10%, then we look at the PVs. So So year one, the total operating cost was 676,000 789,372. The next one is 1,271,227, and then last one is 620,076. Now at 10% we have 0.826, no, sorry, 0.909, 0.826, 0.751, and 0.68683. So now we are going to multiply the discount factors by the total operating cost. So 676,000 multiplied by 0.909 will give us 6144. The next one will give us 0.826 times 789,372. So 652,021. The next one will be 0.751 multiplied by 127,1227, and that will give us 954,691. And the next one is 0.683 multiplied by 620076, 620076, 620076. That one will give us 423,512. The nearest one. What is the total? So the total is going to give us 423,512 plus 954,691 plus 652,021 plus 614,484. The total here is going to be 264,4708. So that is the present value, the PV of variable cost, or PV of operating cost. Okay, now so the sensitivity analysis of operating cost is equal to the NPV over the PV of operating cost. This implies we are going to get 366,722 divided by 264,4708, and this is going to give us 366,722 divided by 264,4708, and this one is going to give us 0.1386 or 13.86%. Can you explain it for me? What is the intuition? What is the intuition? The intuition is that if operating cost increases, by 13.86%, projects will not be viable or worthwhile. Okay.